we want to look at some detailed information about quadratic functions. Here's a typical quadratic graph. Here's some others, various forms for the functions, but the graphs all are parabolas. We need to find the x-intercepts. Now the x-intercepts are where the function touches the x-axis, and notice that the coordinates on the x-axis all have a y value of 0. So this is our technique for finding x-intercepts. We replace the y, which is f parentheses x, with a 0. That produces a quadratic equation. We need to solve the quadratic equation. We learned that back in beginning algebra. Either factor or use the quadratic formula. We can factor this one quite easily. We set each factor equal to 0, and we get the two x-intercepts. To find the y-intercepts, we notice the y-intercepts where it touches the y-axis, and all points along the y-axis have an x value of 0. So our technique for finding y-intercepts is to replace the x with a 0. We just do the calculation, and there's our y-intercept. This is a very easy thing to do on the calculator. Maybe I'll show you that in class. Now the vertex is a very important part of a quadratic function. To find the vertex, that's the lowest or highest point on a graph, depending upon what the graph looks like. To find that, we have sort of a magic way of doing it. We take the quadratic formula without the square root part, and that gives us a formula for the vertex. There is a formula for the vertex on the formula sheet that you use on all your tests. We substitute the values for a and b, just like we do in the quadratic formula. That gives us the x-coordinate for the vertex. We take the x-coordinate, substitute that back into the function to find the y-coordinate. Now, drawing the graph, we won't say a lot about that other than you need lots of practice and understanding about the section that we just did. We'll use our calculator with appropriate window modifications. Maximums and minimums. Now, there's just a little tricky part about how you specify maximums and minimums that we need to understand. But basically, it's just a matter of finding the vertex. Here's a quadratic function. The graph is a parabola opening upward. That means the dot at the very bottom is a minimum. So to find the minimum, we just need to find the vertex. We've already done this. We use the magic formula, substitute the b and the a, substitute that into the function, and that's the coordinate of the vertex. Now here's how we want to specify our answer. The minimum is, that means the y value. The minimum is at, that means the x value. Here's another one that's opening downward, and the point at the top is a maximum. It's still the vertex. We use the same procedure. Using the vertex formula, we substitute the b and the a to find the x value. We substitute that in the function to find the y value. And then we do the same interpretation. The maximum is the y value. The maximum is at the x value. Now the range means the y values. Here's a graph, the same one we've been doing. We've already found the vertex to be 3, -1. The y values, where we see a graph, would be from the vertex upward. So the vertex, the y value there is a -1. It means upward, it goes on forever, so that's infinity. Now in interval notation, we would write that as -1, infinity. And since there is a dot at -1, it has a bracket on the -1. Infinity always gets parentheses in interval notation. Now the last thing we need to be able to do is to take a table of values and use our regression feature of our calculator. So notice on this table we're told that x equals 0 represents 1980. We'll replace the 1980 with a 0. That means 1985 would be a 5, and so on. Now we want to take out our TI-84, do stat edit. We'll type in the values exactly like they are in the table. Match them up like they are in the table. If you need to clear out what you already have in L1 and L2, you can cursor up until the L1 or L2 is highlighted. Press the clear and then the enter, and it'll erase the entire list. Then we do stat calc, choose number 5, and this is what we have. Now, interpreting that, our answer is the function that we see here.